In this clip, I'll show you the mathematical definition of elasticity of demand, and then I'll show you how we can use it to turn the linear demand model from a line on a diagram into actual math. First, let's look at the definition of elasticity. The elasticity of demand with respect to price, which we denote as epsilon sub q comma p, that is to say the elasticity of the quantity demanded with respect to changes in the price, is defined as the percent change in quantity that results from a 1% change in price. So essentially it's a measure of the responsiveness of demand to changes in price expressed in proportional or percentage terms instead of actual units of quantity and price. We can denote this mathematically as percent change in quantity divided by percent change in price. Now, the percent change in something is the change in absolute terms divided by sort of the original quantity or price. So it's delta Q over Q divided by delta P over P. Now we can rearrange terms and we get delta Q over Q times P over delta P, and we can further rearrange to get delta Q delta P times P over Q. So if you look at this, you see that is simply the change in quantity with respect to price in absolute terms, and then somehow scaling it by the ratio of quantity and price gets it into percentage terms. For our purposes, we're going to want something expressed in the language of calculus. Now, this change in absolute terms is approximately equal to the derivative of the demand curve with respect to price, partial Q, partial P, times P over Q, because the derivative is sort of the rate of change at the margin at a specific point, the instantaneous rate of change, which is simply the calculus version of this rate of change. Now, technically, the elasticity of demand is negative. When price goes up, quantity goes down. But for simplicity, we will work with sort of the absolute value of the elasticity. So essentially, we'll just be taking something that may be reported in negative terms and treating it as a positive number. Elasticities in the real world may be expressed either way. Now let's talk about how elasticity fits into the linear demand model. Now, the linear demand model, as you know, is simply this equation. A quantity of a good demanded is equal to some intercept A minus B times P, where P essentially is how much quantity goes down for each unit increase in price. We can rearrange that and get the price as a function of quantity by simply solving for P, and what we get is P equals A over B minus 1 over B times Q. This 1 over B, or rather negative 1 over B, is the slope of the demand curve the way that we typically draw it, which is with P on the vertical axis and Q on the horizontal axis. So what we want is an estimate of 1 over B as a function of the elasticity, or B as a function of the elasticity, which will be just as good. Let me show you what I mean. The elasticity, okay, and I'm going to leave out the Q comma P subscript. And again, we're talking about it in absolute value terms. So the elasticity we defined as the absolute value of the partial derivative of the demand curve with respect to price multiplied by the ratio of price and quantity. If we apply that to the linear demand model, we see that that partial derivative is simply B, or rather negative B. So what we have now in the linear model is that the elasticity is the absolute value of negative b, the derivative of quantity with respect to price, times price over quantity. And because we know that negative b is a negative number, we take its absolute value and we simply get b times p over q. We can solve that for b and we get what we came for, which is the parameter b in our model as a function of the elasticity and also price and quantity, which hopefully we have some real-world observation of. Obviously, if we can come up with a formula for b as a function of the elasticity, we can simply flip it on its head, and we have 1 over b as a function of the elasticity. It's just 1 over the elasticity times p over q. In the next clip, we'll take that computation of the b parameter from the linear model as a function of observable elasticity, price, and quantity, and use it to make quantitative predictions of the change in quantity and the change in consumer surplus that is caused by a policy.